So previously I created a very basic Apex network. If we select the animate node and activate it, we'll have a single point which we can move around in the viewport. This is reasonably straightforward. However, we have an issue. In order for a graph to be more practically usable, we need to extract information from that graph. We should also be able to pass information into it. There is an Apex node which we're going to use specifically for this. I'll find this under Animation Apex, and the node is called Apex Invoke Graph. There are actually two Invoke nodes. There's the Invoke Graph node and the Invoke Scene node. The Invoke Scene node will not be used in the main part of the Apex network. We'll generally use this to visualize animation at the object level. The main use will not usually be to affect the graph itself. We can look at this node later, but do not confuse it with the Invoke Graph node, which is the node which we need now. The Invoke Graph has two main inputs. The first of these will be for a graph, and we'll need a graph to be connected to this in order for that graph to work. In order to read the graph, I'm going to connect the graph into both inputs of the pack folder node, as this may not read correctly if there's not a graph connected to the first input of this node. The output from the pack folder node will then be connected to the first input of the Invoke Graph node. After this, I'll connect the Invoke Graph node to the Configure Controls node, and our network should still be working. As stated previously, if there's not a graph connected to the first input of the pack folder node, this may not work. The information coming out of the Invoke node will be stored in our detail attributes. If we look at these in the geometry spreadsheet though, we'll see that we have nothing coming out of this node. We're going to change this, and the result that we're going to be looking for is a dictionary. All the information that we get from this node and all the information that we store in this node will take the form of a dictionary. A dictionary is a data structure in programming which uses a key and value pair. The key is the name which we use to extract our value, and the value will be associated with this key. We do, however, have no control over the order of items within the dictionary, so the key and the value may not reflect the order in which they are created, or the order in which you try and store them. We'll start by adding an output to this node. If we go to the parameter interface for the Invoke node, we'll see that we have two options for parameters. We have input bindings, and this will have a parameter called input bindings. This parameter relates directly to the multi-palm input for the Invoke Graph node, which is the second input for this node. We also have the output bindings, and the parameter which we have here is called output dictionary bindings. I can add an output binding. When I add this binding, we get an attribute in the detail attributes, and this attribute is called palms. We can look at the parameters we've added to the parameter interface, and there are two of them. The first of these is currently set to output. This is actually referring to the subnetwork output node in our graph. If I go to the graph and change the name of the output node, for example, if I change output to out, this should reflect in this parameter for the Invoke node. It will not change the current entry, but it will change the available options in the drop-down menu. This menu should now have out as the only option. I'll revert the name to output. We now have a direct reference to this node, and we can use it to output information. So I'm going to connect a value from my test point, and I'm going to connect it to the output. In this case, you'll get the translation. This translation value will give us the default translation. We can now examine the geometry spreadsheet in the Invoke node. Our palms dictionary will now have a value in it. This value will have the key, which will be t. This t value comes from the output node. It was automatically generated when we connected our input and received the name of the input parameter. By default, this transform object is at 0 in the world space, so we're getting a 0 vector. So essentially within this operation, we can reference a specific output node. In this case, I only have one. We can then output a dictionary based off that node, and in this case, the dictionary is called palms. This is how we would extract information from our graph. We can use this information in a number of ways. I'll primarily use it for testing, but we should note that we will always get a dictionary. One thing that we cannot do currently is use this information in the animate node, or at least not directly. Currently, the majority of the parameters which we will access will be done through the selection set, although we can access channels, and we'll look at that later. For the selection set, there are two windows for this. There is the tab window, which is called the selection set window, and there is a window within the viewport which is also called selection set. These will essentially mirror the same information. Within the selection set, we can only really access the test point. So currently, all that we can actually access is the transform object. So that's the basics of getting information out of the network. However, in many ways, it's actually more important to add information to the network. We can do this in a number of ways, as essentially all that we need to do is construct an attribute, and that attribute needs to be a dictionary. This is easy enough to do in an attribute wrangle node. We can also do this in VOPs. There is, however, a utility node which will allow us to do this, and that node is called Attribute Adjust Dictionary. This node allows us to build a dictionary. Currently, this dictionary is called PALMS. For the moment, I'm just going to call this dict, as it makes it a little bit more easy to identify. We'll then add values, and these will be under the set value folder. I will add 3 values. The first values will be the keys. I'll give these rather unimaginative names: A, B, and C. I'll set the type of all of these to be floats, as they are some of the easiest values to see update. To make them easier to identify, I'll make sure that none of these are set to 0. So we've generated our dictionary, and we can now use it. Before we use it though, I'm going to do some more work in the network, and this will give us a little bit more context on how this can be used. So first we're going to take a look at how our network will update our output. In this case, I'm going to add a value to our transform. To do this, I'll need an add node, and I will specifically need to add a vector value. I can connect this in between my transform object and my output nodes, and I'll connect this to the first input. I can then open the parameters on this node. I'll set them off the base value, so I'll set these all to 2, and we can look at the updated value. So I'll select the Invoke graph node, and we can look at the geometry spreadsheet, and here nothing will have changed. My vector is still at 0, 0, 0. So to note this, if we want to edit the parameters on this node directly, we can only edit the parameters of the first value. These will need to be added to a second value, so if we want to add a value directly with this node, the connection will need to be placed with the second port and not the first port. With the second port connected, all of our values should now be 2. We'll continue in the network. I want to be able to convert floats into vectors. I will need a float to vector 3 node. The output value for this can also be added to our transform, and I can connect the inputs for this node to the subnetwork input node. So now we should have 3 values connected, but all of these will have no value, so these will not affect our final transform or have any influence whatsoever. So we'll need to make some updates in order to get these to work. The first update is the most obvious. We need to change their names. They need to match the values within our dictionary. So instead of X, Y, and Z, X will be A, Y will be B, and Z will be C. And these are of course the keys for our dictionary. So these are being added to our transform, but we also should see what happens when these points are referenced directly. So I'll connect all of these directly to the output. I'll do this for output A, output B, and output C. I'll rename these outputs so they'll be more obvious what they are. So these will become dict.A, dict.B, and dict.C. We should now be able to take a look at the output values. I'll select the Invoke graph node. In the output parameters, we now have a dict A, a dict B, and a dict C, but all of these are not being set to any value. All of these are default 0, and this is not correct. And the reason we're getting no values is reasonably straightforward. We've not yet added the values as an input, so we'll add an input binding, and we'll need to specify the dictionary. By default, this is PALMS. I'll change this to dict. Our inputs should now be updated, and they should have the values from the dictionary. Once again, we should note here that if the graph is not connected correctly to the first input, we'll probably not have the correct values displayed here. This is why I've connected the inputs the way I have. If we do not connect them this way, this network will probably not work. So once again, we'll need to connect our graph as well as our packed geometry to the first input. The parameters that we want to add will be added to the second input, and they'll be added as a dictionary. I have made a mistake with the dictionary. This should be C for the last value and not B. I'll then pin this and we can look at the results. We should have our updated transform as well as all of the raw values. When we move the sliders in the parameter interface, the values of the dictionaries should be updated. This is how we'll get information into and out of the graphs with dictionaries. This is still reasonably limited though, as we cannot necessarily use these as freely as we would like, and in this current version we cannot use these directly in the interface for the animate node. They are also limited with regards to how much can be updated within a graph. We need to remember that unlike KineFX, this network will not automatically be updating and is not a completely live network. So we will have a lot more limitations in that regard. There will also be workarounds which we'll need to attach these to the interface. There are easy and obvious ways to do this. These do not, however, fit into my preferred workflows. I will, however, use them initially. So that is how we'll get information into and out of our networks. This, however, will not give us a rig. We'll need to have logic and we'll need to have geometry, and we'll look at adding these in the future videos.